Okay, this is chapter 4, multiple choice questions. Number 1, a researcher wants to study the effect of screen time on sleep quality among teenagers. She recruits volunteers from a local high school and asks them to report on their average daily screen time and sleep hours over 2 weeks. What is the most significant limitation of this study design? The study uses self-reported data which may be unreliable. The study lacks a large enough sample size. The study is an experiment and lacks proper randomization, or the researcher fails to define what qualifies as screen time. And the correct answer is A, as self-reported data is prone to bias, especially for behaviors like screen use or sleep. And option C, people could get mistaken on since it's correct, but it would be for an experiment, and this is an observational study. Number 2, in a randomized experiment studying the effect of a new fertilizer on plant growth, researchers assigned 50 plants to receive the new fertilizer and 50 to receive the standard fertilizer. They grow all plants in the same greenhouse under identical conditions. What principle of experimental design is most clearly being demonstrated by using the same greenhousing conditions? Randomization, replication, control, or blocking, and it's C, control, because controlling other variables like the temperature, light, and water of each plant ensures that the differences in plant growth can be attributed to the treatment of the fertilizer. Number 3, which of the following scenarios would most likely result in undercoverage bias? Surveying people at a mall on a weekday morning about their shopping habits, mailing surveys to all registered voters in a district, allowing participants to choose whether they want to complete a survey, or recording responses incorrectly during phone interviews. And the correct answer is A, as undercoverage bias occurs when some members of the population cannot be chosen in a sample and they're left out from the start because the sampling frame doesn't include them or the method misses them systematically. And option A, people who are at a mall during weekday mornings are not representative of the general population, which would be working adults, which is undercoverage bias. And people could get tricked up on option C, but it's not undercoverage, it's voluntary response bias because the people have the option if they want to respond or not. My first FRQ is, a school administrator wants to estimate the proportion of students at her school who favor a change in the dress code policy. She decides to conduct a survey and chooses to stand at the school cafeteria entrance during lunch and ask the first 100 students who walk by to participate. Identify the sampling method used in this study. I said that this is a convenience sample as she's just surveying the first 100 students who happen to walk by here in the cafeteria during lunch. B, explain one source of bias in the sampling method and how it could affect the results. I said it introduces undercoverage bias because it only includes students who go to the cafeteria at lunchtime. So students who bring lunch from home and eat elsewhere in the school potentially are excluded. And these students could have different opinions about the dress code, so the results could overestimate or underestimate the true proportion of students in favor of the change. And then C, describe a better method the administrator could use to obtain a representative sample. I said a better method would be use a simple random sample where the administrator assigns all students in the school random numbers and then randomly selects 100 of them or however many they want for the survey. And this ensures that every student has an equal chance of being included and reduces overall bias. My next FRQ is, a scientist wants to determine whether a new type of plant food increases the growth rate of tomato plants. She has 60 identical tomato plants in a controlled greenhouse where they will all be grown. A is, describe a completely randomized experimental design that the scientist could use for the study, and be sure to specify the treatment groups and how the plants should be assigned. So I said the scientist could randomly assign the 60 tomato plants into 2 groups of 30 each, where one group receives a new treatment, the new plant food, and the other receives the other treatment, the standard plant food, or the control. And they should grow all plants under the same greenhouse conditions, such as light, water, temperature, and soil, and then measure that growth over a set period of time. B, explain how each of these 3 principles of experimental design, control, randomization, and replication, are addressed in your design. So in my design, I said the experimental controls would be like sunlight, water, soil, and by growing all plants under the same conditions. Randomization, it's plants are randomly assigned to the treatment and control groups, reducing the effects of confounding variables so you know that the treatment's actually affecting the results. And then replication, the experiment has 30 plants in each group, which is a large enough sample to detect meaningful differences and increase the reliability of the result. Question C, suppose the scientist found that the plants given the new food grew significantly faster. Can she conclude that the plant food caused the increase? Justify your answer. I said yes, the scientist can conclude that the new plant food caused the increase in growth because since it's a randomized experiment, random assignment allows us to attribute differences in outcomes and what we were looking at is growth rate to the treatments, assuming other variables were controlled.